Okay, today we're going to be talking about two new techniques that we can use to factor polynomials. So, the first one is called the difference of two squares, and we abbreviate that with dots. So dots stands for the difference of two squares. And this looks like the general form of dots is a plus b times a minus b equals a squared minus b squared. So we're going to learn today how, if you're given something in the form of a squared minus b squared, we can factor that into the form a plus b times a minus b. So you've already sort of done this, but you've done it backwards. So we have used FOIL to compute something like this, but we're going to go backwards today. So let's do a few examples to illustrate that. All right, so as we do these problems, I want to keep in the back of our minds that when we see something like a squared minus b squared, this can be factored into a plus b times a minus b. So let's look at the first one. We have 36a squared minus 16. So I can first recognize that 36a squared is 6a times 6a. 6a times 6a is 36a squared. Also, 16 is 4 times 4. So I already have my a term and my b term. So this, when it's factored, is going to look like 6a plus 4 times 6a minus 4. And now if we were to FOIL this out, this equation here, or this expression, we would get 36a squared minus 16. This is an excellent way to check yourself if you're not sure that your factored form is correct. Number 4, we have s squared minus 25t squared. So first I look at this first term, I see it's s squared, so that's s times s. And the 25t squared is 5t times 5t. So this, in its factored form, is going to be s plus 5t times s minus 5t. Number 5, I have 4x to the fourth minus 9y squared. 4x to the fourth is really 2x squared times 2x squared. So it doesn't always have to look like something squared. You can have a 4 there, or an 8, or a 16, or something even. So minus 9y squared is 3y times 3y. So I have my a and b term, and this, in its factored form, is going to be 2x squared plus 3y times 2x squared minus 3y. And for number 6, I have 1 minus 81k squared. Well, 1 is 1 times 1. So that technically is a square. So 1 times 1, 81k squared is 9k times 9k. So this factored is 1 plus 9k times 1 minus 9k. All right, so now I think you probably have the hang of doing the difference of two squares. So let's move on to another factoring technique. Okay, so our other technique is called PST, or perfect square trinomials. So PST stands for perfect square trinomials. And if you remember, from Unit 7, we talked about polynomials, and you remember a trinomial is a polynomial that has 3 terms. So we're going to have a polynomial with 3 terms, and we're going to be dealing with perfect squares. So a perfect square is something that can be taken, that can have the square root taken of it easily. So 25 is a perfect square. That's 5 squared. X squared is a perfect square. That's x squared, x times itself. So the general forms of a perfect square trinomial are a plus b squared, and this looks like a squared plus 2ab plus b squared. And the other form we could have is a minus b all squared, which equals a squared minus 2ab plus b squared. All right, so let's see these in action with some examples. Okay, so using what we know about perfect square trinomials, let's try to factor these trinomials into their factored form. So using a squared plus 2ab plus b squared, we can factor that into a plus b all squared. Similarly, a squared minus 2ab plus b squared equals a minus b squared. So let's take a look at this one. We have x squared plus 14x plus 49. Well, right away I can notice that x squared is x times x. And 49, this term on the right, is 7 times 7. So this middle term, if this is a perfect square trinomial, should be 2 times x times 7. So 2 times x times 7. And let's see if that's true. 2 times x is 2x. 2x times 7 is 14x. Excellent, that's what we have. So I can factor this into x plus 7 all squared. And now if you were to write this out, x plus 7 squared, I'd have x plus 7 times x plus 7, and I could FOIL and get this result back. That's a good way to check yourself. I really recommend doing that wherever you can. Number 10 is k squared minus 2k plus 1. Well, right away, I noticed this minus here. This tells me something. This tells me that I'm probably going to be dealing with the second case here. So let's take a look. We have k squared, which is k times k, and I have 1, which is 1 times 1. So this middle term should be 2 times k times 1. And in fact it is. We have 2k. But we have minus 2k, so this is going to be factored like k minus 1 squared. All right, number 11, we have y squared plus 10y plus 25. So y squared is y times y. 25 is 5 times 5. And 10y is 2 times y times 5. So this is 2 times y times 5. So this is going to be factored like y plus 5 all squared. And our last one, 25x squared plus 70x plus 49. So here we have 5x times 5x, and we have 7 times 7. And this is a big term in here, but don't feel threatened by that. This is 2 times 5x times 7. 2 times 5x is 10x. 10x times 7 is 70x. So this will be factored like 5x plus 7 all squared. All right, with that, I will leave you to try the problems at the bottom of your guided notes. Thank you.